and welcome to this keynote session on user-designed computing, free enterprise application design. My name is Martin Ralston from Arthur Anderson & Co, and I'm the chairman of this particular session. It's my pleasure this morning to introduce to you, to make his presentation, Mr. Louis Schlueter. He's been associated with the electronics industry for over 30 years, the last 25 of which have been spent with the Sperry Corporation. For the last 15 of those 25 years, he's been directly involved with the development, implementation and marketing of a user-oriented computer system known as MAPPA. He's also authorised numerous articles on the MAPPA system and MAPPA's approach to user-driven computing. He's also the author of a book entitled User-Designed Computing, which is published by Lexington Books and DC Heath and Company. Louis is going to check on the Australian distributor before the conference is complete. Louis's presentation this morning will emphasise the importance of involving users in MAPPA system design and development, and give you some idea as to the sort of productivity increases which can be achieved through using such a tool. He'll also discuss with you a new way of looking at information which he calls real control information, and his philosophy of a free enterprise approach to application development will also be discussed. His presentation also recognises that free enterprise approach to development could also employ anarchy, so I'll share with you some of the controls and techniques that he uses to control application development in such an environment. So I'd now like to introduce to you for his presentation Mr. Louis Schlueter.
Thank you, Martin. Thank you, ladies and gentlemen, for the opportunity to come and talk to you. The subject, of course, that I have to talk about is users, and the users as architects and system designers. The new role of, or a new approach to computing requires a whole new bunch of concepts, but it's a way in which we can get computer power implemented and perhaps deliver the full promise of computers. And I'd like to discuss how this is all possibly done. Computers, as we well know, are very fast and powerful. We've seen, thanks to the chip technology development through the last years, many magnitudes of improvement in performance for the computers. This has been indicated and made available to us in the form of the explosion of personal computing power on the small personal computers, as well as mini computers, and even the basic costs of the large-scale systems coming down dramatically, primarily because of this technology and chips. We've seen the power multiplied many times in the last 10 years. It's been suggested that maybe if the auto industry had done the same thing, we could all be driving around a very nice automobile and get about 5,000 miles to the gallon, and that thing would cost about $200. In other words, in terms of performance for the dollar, the computing industry has definitely come through with this chip technology. We really have, in terms of computer power, there is no energy shortage. The problem, however, is in the area of programming. We have a lot of computer power becoming available to us at very reasonable cost, but the instructing and programming of those hardware capabilities is where the limitation is. We definitely cannot get enough programmers to do all the things that we want to do with computers. There's been studies made, projections, and these have been pretty well documented in the industry. Something like 300,000 is possible that could be trained in the 80s. And if we really wanted to do everything we wanted to do with computers, we would probably need something like 28 million. Obviously, we can't get enough programmers to do all the things that we want to do. And it's an expensive type of labor we're talking about here. Programmers are well paid, and there's a lot of labor involved in the programming process. So it's really a serious limiting problem. We've also seen extensive organizations developed to deliver conventional programming for the users. Whole organizations of analysts and planners and specification writers, and then, of course, programmers have been created. Sometimes these have actually become very bureaucratic in their ways and haven't responded as effectively to the users as they should have. There's been even some accusations of analysis paralysis going on in situations like this, where requests are made and they never seem to come out. The programming bottleneck is indeed a greater limiting factor to the economy than the energy crisis. If we could employ all the computer hardware power that's becoming available in the industry very, very effectively, this could have tremendous productivity improvements. It's also been, studies have been made, and these kind of figures have been showing that any existing programming resources that are available, a great part of that is used for maintenance of existing systems. In other words, there are many complex systems that have been developed over the years and have become very complex in their internal structures. A lot of the programming resource then is now being spent in just maintaining existing systems and adding new features to those systems. A very small amount of the available programming resources are available for new application development. It's a situation that might be compared to what happened in the telephone industry some years ago. In the days before the dial-up systems that we have today, we had the manual operator intervening on all telephone calls. So you got a hold of this person and you gave them a telephone number and they would plug you physically into the connections that would get you to where you wanted to be. And the telephone industry recognized that that was very limiting, this personal intervention on every call. So they put the switching mechanisms into the computers and then put the control of the computers in the hands of the users. In other words, with the dial-up mechanism in the hands of the users now, you could dial directly in and control the computer switching, and that, of course, opened up the potential for the telephone industry as it has expanded and become today. Now, being mostly computer people here, I'm sure you know these two classes of information. Not all users understand what they are, but we know them as real-time and batch, and this is a very common couple of classes of information that we've had in the past. And this is the way we've been delivering most of our information for users. I'd like to suggest that we need to look at another class of information which hasn't been serviced very much at all yet, and that is what I would call real control information. Let me give you some characteristics of this kind of information. It's really measured in terms of controlled effectiveness. In other words, if the information can be accessed in time to control events in the operation, then it is real control information, as I define it here. If not, it's reference data. Now, the massive computer power that we have is very good at processing massive amounts of data. And quite often, a lot of the stuff coming out of computers is best classified as reference data, not really control information. Some of the nature of this real control information is what we see in our businesses. If we go to our office and begin to analyze how we process information in our daily tasks, these are the kind of things that we're doing, really. We're processing transactions, activities through our operation, and in order to do that, we normally have to be concerned about events that are going to occur in the operation. So a little preliminary planning is very volatile for us. We have to do a lot of things to get ready for events about to occur. Transactions in the operation are extremely important, and this is probably the biggest, the most important aspect of real control information, to be able to control events while they're happening. In other words, tracking tasks through the operation, make sure nothing gets stuck along the way, prioritizing the jobs to make sure that the proper things are done that are most important first, and moving everything through that operation, expediting, status reporting. These are the characteristics of the most important part of control information. And then transactions that just left the operation. This is the characteristics that you need when you just finished the job. Normally you got to know when you finish it, what were the costs. Somebody's going to check on that right after it happens. And then it becomes history. Then the item becomes a reference set of data and really passes out of the view of control except in grand summary types of analysis. But in terms of momentary control, we really have this idea that the data flows like maybe through a window of time, or the stuff about to happen, we have to worry about that, so that's part of our view of the data. While it's happening is an extremely important view of the data, because that's what we can use to control events and keep things really moving. And then as the data, or as the transaction completes, then an immediate history follow-up, that's also important part of control. So we see this view, and the data is flowing through in front of a person in this way, and after that, it becomes history. This information is relatively small sets of data. The human mind does not process 1 million records in one thought. It really is chewing up information in small sets small pieces. So it's very transactional in its nature. It's very dynamic information, very changeable. The new in and the old out is very common, this window of time sort of a situation. It must reflect current conditions. It's a very important aspect of real control information. You can't control events if you tell me I did it last week. Unless I make the same mistake every week for a while, the pattern will begin to develop and I can make a corrective action. I need control right now as the events are happening in order to be effective and to really get real control information going. It's ideally formatted to be useful. In other words, each operation, each office, perhaps even certain desks within an office need a different view of the data. And this is ideally, it must be ideally formatted in all these different ways so that people can see exactly what they want to see and not be cluttered up with all kinds of extraneous fields of information that don't really pertain to the control task that this one individual or this group of people are involved in. So a lot of formatting flexibility is required. The real control information is used to initiate action, to get things going, start the jobs, report the current status, extremely important aspect of that, and then expediting things along, making sure nothing gets stuck, making sure the queues all move along. Setting priorities is very important, to make sure the proper things are done and to be able to change priorities very conveniently and have that reflected immediately so everybody's working with the proper set of priorities. And then the what-if planning is also part of that. These are all characteristics of real control information. Now, right now, we haven't computerized very much of this yet. Most of it is done in paper mills, and if you walk through most offices, you'll see a lot of paper still being shuffled through the ins and the out baskets and in the mail and all sorts of things. Lots of telephone calls going on, things like this. In other words, real control is not being done too much with computers. Granted, there are some major applications up and running, but a very small percentage of this kind of information has actually been computerized. It's not easily accessible in all these paper mills and scattered all over on all these desks. The only way it becomes accessible is if you stick it into a Xerox machine and then distribute copies all over the place, or route it around through the office with a routing slip on it. These are ways of communicating. Very inefficiently processed. So you're doing a lot of telephone calling and that sort of thing in order to process this information. It's very parochial. Like I say, very specially formatted for each individual situation. It's varied. The requirements are varied in terms of each person and each part of the operation needing different things. And it's changeable because the operation keeps changing. There are no locked-in systems or locked-in operations that don't change, especially nowadays. Change is a very important part of everybody's operation. Really, it's individually too unique and varied to program conventionally. It's been talked about that studies say that we have these programming backlogs, and I guess it's been pretty well documented that the average DP shop has something like 2 to 3 man-years of backlog of application development that's in the mill, and that seems to be pretty average. But there's also been some talk about something called an invisible backlog. In other words, users know that they've already made requests that are going to take a year or two to get to, and so they've stopped asking for a lot of other things that they would like to do with computers. And that's really where this real control information falls into. I think that this is part of a majority of the invisible backlog. These things are not even being asked for because, well, it's just too varied and unique to program conventionally. And then they see already why, how it's so difficult to get the larger scale applications developed. But if we could computerize this information, if you could really implement computer power on a grand scale out there and do these things, obviously the productivity potential is enormous. Make sure you understand the perspective here. Very little of this has been computerized up to this point. Now I want to talk about how we might be able to do that. To do it, I suggest we have to look at this whole role of computerization in a different way. Maybe we need a free enterprise approach to computer application design. Basically that says give the users freedom to do their own application development. If we do this, we're going to see some strange things happening that we're not used to. The users as system architects, when they start using tools like this, the mystery will disappear. All of a sudden the semantics and all the mysteries of using a computer will disappear. The languages will be simpler. People will be able to understand them very well. The computer will become just another tool. As they've learned to use the calculators and the typewriters and all these things, they'll learn to use this too eventually. And then when they do that, they'll be able to computerize this remaining information that's so varied and unique. The reason we need the free enterprise approach maybe it's because we also need it in the economy. And similar to a free enterprise in the economy, we may have this invisible hand effect. And by that I mean, if you remember from your economics, Adam Smith defined the situation where the entrepreneurs throughout the economy and all the businesses decided what to produce on the basis of a product that would seem to have some acceptance, with only one thought in mind: to benefit themselves with a profit and a benefit for themselves. They didn't really intend, by deciding that there was an organization or a bunch of people out here who would buy this product, making that gamble and deciding that there was a market for that information or for that product. They decided that based on that view of the marketplace and with only one idea in mind: to help themselves, benefit themselves. And Adam Smith said when everybody did that, all these entrepreneurs and all these businessmen did that on an individual basis, each choosing their thing and trying their method, that the whole economy benefited with the invisible hand effect. In other words, the best things were done at the right time, and the whole economy benefited. And probably the same effect can happen here. If the users are allowed this freedom to implement in each department, in each operation, the proper things as they see it in their view of their part of the operation, then there will be also an invisible hand effect which will benefit the entire operation, the entire institution, or the entire company. When they apply these application developments in their operation, they will be applying them with the best possible set of priorities. They will decide in their department, in their office, with their experience with this thing, what is the first thing I should do? And where will I get the greatest benefits from right away, in the best possible way, in our environment here? So they'll set the best possible priorities. They'll be doing this in the fastest possible way, and I want to talk about the languages that are involved here and the kind of leverage that they have for application development. And indeed is an extremely fast way to generate applications. They will get the greatest benefit at the most labor and material intensive level, and that's extremely important. In other words, out there in the user departments where the most material and labor is involved, and we're talking about large numbers here, you'll get the greatest productivity benefit immediately. And of course, when the computer power is provided to these people know their jobs, they know their problems, they know the things that they want to solve, that they want to computerize. They don't have to define our specification to somebody else that'll do it for them. If they can use this tool to mold that power directly to solve their problem, it is very effective, and it's really an amplification of their intellect. So the combined intellect of all those people out there in all those offices and all those operations are given computer power, and that amplifies their abilities tremendously. They will be able to do user-oriented application design in 1/10 of the time than you would doing conventional application development. Now, we want to be sure we're talking about real-time application development. We're not talking about simple COBOL straight-line programming here. This is the most difficult kind of programming that there is to do. Typically, you can't even do it with COBOL because it isn't responsive enough. It isn't fast enough to do this job. You're talking about really the equivalent of this would be assembler-coded programming, where you would actually have very detailed application development on a real-time basis. In other words, it's transactional. That says it's very fast response times. You're talking about database design considerations. You're talking about update conflict resolutions, because you're talking about real-time updating here, where events are going to be reported as of this moment to reflect in our operation real control information. So as events are changing, they're immediately reported. We're talking real-time updating. That implies automatic recovery and backup systems, history production, automatically produced. All these things are part of this application design. It is the most difficult kind of application design that is done conventionally. And they will be doing this in 1/10 of the time. And the reason for this is because the functions become powerful instructions. There's a lot of leverage in these functions. Let's talk a little bit about a function as it appears in this new approach. And let me go back to some real-world experience on my part and with the mapper system, which is what I've been involved with through these years of development. There was a concept called report processing, which was defined back in 1968. Back in the factory in Roseville, Minnesota, we had a need to solve some problems for the users there. In fact, there was an assignment to do a real-time inventory control system for the test operation. They have a lot of equipment in final test in our computer center there. And they wanted real-time inventory control. And the assignment came to write a test inventory control application. Well, really what they wanted to put online was, with terminals in real time, be able to access this information. They wanted to put online vertically field-formed lists of data that showed these are the items that are in test. This is the status code on the items as they're being processed. This is dates relative to that, quantities, dollars. In other words, vertically tabular field-formed lists of data with appropriate headers across the top. Now, if we'd have developed a conventional inventory control system, that would have been the end of the story there, and I wouldn't be here talking to you today. Instead, a little different approach was suggested. Instead of designing this one form for this one application, we said, let's develop a form generator, okay? And then we could define forms in this format, vertically field-formed lists of data, in any combination of size fields or arrangement of fields and appropriate headers across the top. And with this form generator, we would execute this form generator, and it would lock onto this form and give it system protection and edit control without programming, and create all those automatically. And the connections to the database, maintenance and recovery and all that sort of thing, by simply defining this form. And that was the form generator function, which was kind of the key to this whole thing. So now we were able to put the inventory application on, and any other application that we could define in terms of these vertically field-formed lists, and we could do a form generation. Now we had the form online, and it could be displayed with the terminals, the screens. It was a real-time system, and they would do an add report, and they'd have a blank form created then, and it would just be with the appropriate headers up there and blank fields underneath, and the users could then real-time update that information. They could start actually updating the items in the inventory in there, and then changing the data as events happen, changing the status codes and the dates and the dollars and whatever. In other words, they had a real-time reflection then by just direct updating into these reports. Well, that put the data online, and it made it available very conveniently, but now it was obviously there was more desire than just look at it on the screen. They wanted to process that information, so we began to develop what we now call report processing functions. And well, of course we had display, and a print function was very quickly needed because people wanted a copy of this information to take out of the system. And then we also developed a lot of powerful analytical functions. The first of these was search. Then we provided a way of searching any report in any format with any one of a whole combination of search criteria, and therefore now they were able to get answers out of their base very quickly with a search process. And again, this was done without programming. And it became very quickly obvious they also wanted things in different orders. The database that they put online was vertically field-formed and was in order by usually some criteria like the part numbers in the initial case. And that's fine for having it online, but people want to see things in other orders. So they would do a search, and they'd have a search result, and they'd like to sort the search result into a different order by status code or by date or quantity or something like that. So a sort function was provided. It could be used on any form in any report, again without programming. And then it became pretty obvious that there was a lot of numeric data in these fields, quantities and dollars and things like that, and people wanted to work these numbers. So we provided another function called totalize, kind of a calculator or compute function. And it could work numbers in fields very conveniently, again without programming, adjusting to these formats automatically. And that allowed them then to take the numbers in these reports and turn them into more useful numbers, or with subtotals, grand totals, averages, cumes, subcumes, grand cumes, and all these kind of things. So they had another function for that. And then we added a match function because they began to want to relate data in one report into another. So they built them a match function that would match some of these together. Well, this whole concept started 15, 16 years ago, servicing mainly this user community in the factory, and we began then to develop the functionalities for it. And we added new functionalities on a new release periodically, and we're still adding new functionalities on releases. Just recently we added one that added word processing functionality and color graphics functionality to this report processing. So it's continually evolving and has been evolving over all these years. We've gone through several database redesigns for efficiency purposes. And in other words, this whole evolutionary process has been going on. And we provided over now 100 functions that are available for these people to execute interactively. When the thought comes into their head that they want to analyze their data a certain way, they can do that. And then they can also string these functions together, and the functions then become instructions to a language, which is called a run language. And now they can make statements like search, sort, totalize, and so on, and they can create applications with this, using the functions as instructions to the language. The database design is very simplified. we have an electronic filing cabinet view of the database, and I'll explain that to you a little later. The users can design the databases that they need here very simply. There's an automatic recovery and history provided for them, so as the updates are made in the system, automatic recovery is provided and a history backup so they can see reports on any day as long as they want to keep these magnetic tapes giving them the history. They're retrievable. System monitors have been developed also because over the years, as we grew to higher and higher levels of service, we also saw that you could not just have a user-oriented service, you also had to be able to control that effectively. So we started out with just personal coordination processes, in other words, people coordinating other people in the use of the system, but that became quickly obvious as not being totally adequate. So we began to develop computerized assistants for these coordinators. And again, that started about 10, 12 years ago, and we began to develop functions for coordinators to deliver the service in a very effective, efficient way, in a very controlled procedure. There's fast interactive design and debug involved in this because it is a real-time system. As these users are designing applications and writing these statements and things to create procedures of use, the statement is written, it's executed immediately. If it works, fine. If it doesn't, the system comes back and puts a diagnostic key on the subfield that's wrong and gives the user a diagnostic as to what correction is to be made. The field is corrected with an update, and you transmit and try again, and it's very fast interactive debug processes here. The net result then is real-time application development by users in 1/10 of the time. Had they gone through conventional requests to do all this, it would have been, well, it would have been impossible to begin with just to define all these requirements. But the fact they're doing real-time application design in 1/10 of the time says that there are tremendous programming savings involved in this approach to computerize information on great scales and have tremendous programming savings involved in that. This database view I was talking about is conceptually to the users an electronic filing cabinet concept. They're given the name mode here, and it's just a grouping of types of reporting. The file cabinets or modes are usually given out to individual departments. So an individual department that wants to use the system will be assigned a file cabinet, and then within that, the drawers of the filing cabinet are called types of reporting, and generally they will be on different applications. So, for instance, in the case of the factory back there, we might have one where we would have type B would be test inventory control, type C might be shortage reporting, type D might be failure malfunction reporting, and the point is then each drawer becomes a different subject of reporting. The data within a given drawer is usually the same field orientation and form. In other words, the same general subject all the way down through the drawer, and all the data in there having the same columnar relationships. In one of the drawers, or in one of the types, we would have reports. And I guess that's why it's called a report processing system, because just as a user takes a folder out of the file cabinet and over to the desk and works with that, processes it, puts it back, that's the kind of a thing that happens here. These reports are updated, they're searched, they're sorted, they're totalized, and there are inter-report functions that can cross reports and draw data and collect data in different reports, as well as across types. So there are functions that can do all that. What you get right off the bat, and one thing that's beneficial here, is a very simple file naming convention for the users. If they want to have a new type of report set up, it's done with the form generation process to define the form, and then as they create the reports, they're automatically numbered for them, so that if I want to see, for instance, report number 2 in the bottom drawer type I, my key in is 2I and transmit, and it displays the report. So we don't have any long file name key-ins to remember, no complicated. Most of the things you can do with the system are done with 2 or 3 keystrokes and a transmit. So you're very quickly going along and doing things without a great deal of memorizing of long sequences of words and things like that. It is possible to have large databases set up in this system. Just as the users have organized large amounts of information in filing cabinets, they can organize it here too. Most of the applications we're talking about, and really that's where the big multipliers come into effect, is the ability to computerize all these very small parochial applications in all the operations, all the things that are in the invisible backlog that aren't even being asked for, but are very inefficiently being done in paper mills and very crude operations in the various departments and organizations. Now those can all be computerized with terrific productivity benefits from that. Just computerizing all those things give you a lot of man-hour savings in a lot of little cases all over the operation. And you can imagine how it would be very simple with this file concept to organize a dozen or so reports that reflect a situation in a certain application, like maybe break it down into 12 reports, one for each month or one for each week or whatever, some simple organization that's useful. And so most of these applications have very little trouble developing an organization within a simple concept like this. But that's not to say you can't use it for a large database organization. Just as the users would organize a large filing cabinet set of information, they use an indexing system of some kind. So they'll select one drawer or one report or so and use that to reference with reference indexing to point out into other reports, into other drawers, and to indicate relationships in the database. And many large applications are put on in that way. You can, for instance, have up to 2,000 reports in one drawer, one type. And quite often in the case of a large database, they will take 1,000 reports and set them up as a set of, if you will, data buckets or data sets through this type. And then, based on some kind of a formula, they will use the report number as a data set to store records in. So they've essentially created a database organization here, and then they might spread the, for instance, an inventory base across the 1,000 reports with some kind of an algorithm that says this part number, based on maybe the most random numbers, that random number or a hashing algorithm or something like that will designate the RID number that data is actually stored in, and then they will use a find or a binary find or something like that to actually locate the specific records within the report. So usually within a matter of just a few accesses to storage, they can get at any records in this entire system. First level index is the reports themselves. You can get at any report in the system with no more than 2 accesses to storage. In fact, on the second access, you're outputting data onto the screen. If you know which line in the report you want to get at, you can actually go to that directly and put it out on the screen with no additional indexing. So simple organizations, which is where the big multipliers are to do all these things in all these offices all over the place, simple applications are easily organized, and more complex ones then are using the reports as data sets and some kind of a formula for distributing the information amongst the data sets. This is a typical report, as I was talking about. Vertically field-formed lists of data. A very universal form of information. Everybody can imagine how they could organize some useful information in this way. When users get involved in this application development, they are given an experimental report. It's a free-form report with no headers on it, and they're given a little set of guidelines on how to design headers and lay out the general form of something like this, and then told, now go back to your organization, talk to the people who are going to use this reporting, and you design the form the way you want to see it. And they'll lay out a set of columns here with appropriate data, relationships, customer names, account numbers, whatever, and they'll lay out the headers across the top and decide, this is the way we want this form to look. It all really starts with the coordinating function, the user requesting the idea to be put online, and then the user assigning the experimental report to them for them to design in and gives them some literature and stuff to some advice on how to get started. They lay out the form, they come back to the coordinator, and there may be some interchange there where the coordinator might recommend some improvements. There usually is a little bit of policy document when there's some of the standard fields, like in a given operation you may decide on a standard date format that you want to use, or a standard account number format that you want to use in all your reporting, so there's some consistency. So you might have some policies to start with to guide the users to lay out some consistencies in their form designs. But basically they will decide how these fields are arranged and what the headers are and what's appropriate. They come back, coordination works with them and makes sure everything is the best possible design. Then a form generation process is done. And of course, prior to this, an application was created and a plan was developed for the application. So we know what we're putting on here. But form generation is done then by the coordinator, in which this form is locked onto and given system protection, and the ability to create reports then is created immediately. Now the users at that point can do an add report function and get a blank form set up with report number 1 assigned to it. They can start loading data in immediately. The form generation process takes a matter of minutes. I'm talking about man hours involved in application implementation here. As soon as the users have that form defined and everybody's agreed that it should be done, it can be done in the actual step of turning it on is a matter of minutes. Now the forms are there. They can start adding data immediately. They can start loading their database, putting events into these reports and reporting on the status of things. And as soon as it's loaded, they can start report processing. They can start searching and sorting and totalizing. And so applications can be turned up so quickly, just as soon as they can be conceived, they can be loaded and put up and running. So it's a very fast implementation process. Now, this is a very important slide that I have here because it is the key to why users can understand this concept. The data has become the language. When the user has laid out this form, they've decided these are the headers I want on my data, and that form is generated, automatically a function mask is created for them by the form generator process. Okay, what happens then is when they've got the data loaded in the report, as you saw in the previous slide, now if they wanted to search that report, for instance, they would call for a search function. And the search function, they would specify, I want to search this report and this type and transmit. The system would then go out and extract the function mask, which would consist of these headers across the top here, and this line of asterisks, and that would be presented on the screen as a function mask. The line of asterisks here is used for character position control within the fields. So in other words, if I wanted to do a partial search of this product type number by erasing some of the asterisks, I would be limiting the field size on this particular field. So you get character position control within the fields. That's what the asterisks are for. But the mask appears on the screen, and then the user, to implement the search, actually inserts their own data under this mask. For instance, the user may have decided that I've got a status code field here, and I'm going to code all items that are shipped as SH in my database. That's the decision the user makes. So now when they want to pick up all the shipped items on a search process, they simply key in SH and transmit. And back comes a result from their reports with all the items that have an SH status code in that field. This is a simple single identifier search for shipped items, for instance. If you wanted to have an OR condition to have more than one item in a field, for instance, maybe by product type, you might say a certain product, another product, and one of the rules then of this thing is whatever you list vertically under a field is an OR condition, this or this or this or this. So there's your OR condition, and you can do that right down the list underneath a given field. The AND condition is specified as a horizontal relationship. For instance, if it's shipped SH on this date, 82/11/15, that's an AND condition, and you'll find all the items coming back in a search result that have a shipped and that date combination. A range search is also used a lot. For instance, in a serial number field here, 500,000 to 700,000. And what makes this a range is the fact that this R was placed on here. Otherwise, that would have been an OR condition. But with the R attached to the second identifier here, that has become a range condition. It'll pick up any serial number in range from 500,000 to 700,000. Range searches are very valuable. Range searches can be done on, as it is here in the case of serial numbers, can be done on cost fields for costs in range, dates in range. Got some production plan actual dates over there, dates in range, alpha names in range, just a whole bunch of things that you'd want to do with range searching. In fact, under search, you can combine any number of fields vertically or horizontally for or AND conditions, attaching R's to team up things for ranges, and be able to knock out asterisks and control selected characters within fields here to control that aspect of search. And obviously what you have is a very powerful question asking capability with a simple search concept. And can the users understand it? Absolutely, because the data has become the language. These are their headers. This is their data. They're placing under their own data to accomplish the transaction. How can they fail to understand it? And they do. They understand it very nicely. If you want to do some arithmetic, you might have a cost field with some numbers in there. You call a totalizer function or a calculate function. And then you do something like, if I want a vertical sum, I put a plus in that field and transmit. And it does a vertical sum on that field and takes the headers off that field and attaches to the vertical sum to give it meaning. Automatically. You want to do some data analysis. Real control information has the characteristics of usually having time and date in it. Well, you can process time and date with the date function. And here you have, for example, of taking a production plan, dates, and subtracting it from some actual dates. And if you put an equal in another field, it'll give you a number of days difference between those dates. The point here is that the data has become the language, and it's probably the key to why this system has had such acceptance. Because when the user lays out their database, they are creating a very nice language to operate within here. Now when they hit transmit, they put in these parameters and they hit transmit, a result is produced immediately based on the criteria of their selection. Now this is a different report, different headers, was worked up with a series of search and totalized processes, subtotaling, and I reduced this down to a set of data which is a different class for each item there, and there's some quantities that have been subtotaled by class. For instance, here was a result that was produced by executing some of these other functions and ending up with this transient result on the screen. Now if I wanted to go further with that, you can process results with functions, so you're not limited to just one step in the process. You do a search, a sort, a totalize, or whatever. You can work the results from the previous function and continue to enhance it in many different ways by executing all the different types of functions on that data. Well, this is an example of a result produced, and maybe I'd like to have this graphically processed into graph. Okay, so here's the way that would be done. We call for the graphic function, and that function mask is presented. And again, these are the headers from that report, presented on the screen with the asterisks in place. Now, the rule is for all of our functions, and by the way, there's 100-some functions, and they have many options. It isn't just a function that will only do one thing, but within the function, there's lots of options. And one of the rules of our using these function masks is, if there are options that can be used, they will be put above the mask. All right, when you call the graphic function, the B option says produce a bar graph. And you got pie graph, and you got a line, and you got a few other different kinds of graphs you can select. In this case, selecting a bar graph, and by putting an L in this field, we're saying this is the labels for the bars, and by indicating next over here, it's a quantity. Now you can get a little more elaborate with this and specify under here, you can specify some different colors and patterns and things like that if you want to be a little more artistic, but this is a very basic request for a graphic capability. Of course, there could have been more than one field being bar graphed here too. This is a simple one field quantity charted with this as the label field, and a bar selection has been made. And transmitting produces this result as the next step. It's just that simple. And that's a very user-friendly graphics production. It's easy to understand and has immediate results in that sense. Now there is a more formed way to do this where if you want to get a little more artistic with your graphics, you can set up a formed input where you got a whole bunch of option choices and kind of like filling out the form with the title, the subtitle, and whether you want 3D bars or not, or if you were using lines, or you want fill lines or not fill lines, and all sorts of options can be selected in a kind of a menu selection, which is a little more artistic. But this was the most versatile and simplest form of interaction with graphics. And you can see how that could turn numbers into pictures very quickly and be a very powerful way of having real-time interaction that is very effective. And I think that you can get a lot more out of a graph because you can see the quantities and the extent of deviation between the quantities very quickly and across the scale in a way that would take you a lot longer if you had to sit there and analyze the numbers and determine this without graphs. Now these users, as they're implementing these applications all over the place, they're usually a little nervous about the whole idea when you start out. The coordinator demonstrates some of this and has some guidelines for them and some tutorials for them to work with, so they're guided into the whole process. But nevertheless, they're a little nervous. So they get their form generated and they start to load their data in, and it begins to reflect reality. They do a bunch of updates and they get this stuff going. And they print it out immediately. As soon as they've loaded some information, they print that out immediately because they don't even trust this thing that it's going to be able to keep their data for them very long. So they have printouts made right away whenever they have to update, and then they keep updating, and they begin to report the events in their operation, and they begin to realize that, by golly, this is reflecting my real-world situation here. And the next day when I call that report up, the data's still there. It hasn't lost it. And, this really becomes quite a tool. So they begin to load their stuff in, and confidence develops then in the system and in their ability to use the system and accurately reflect what's going on in their operation. Confidence develops then in their applications, and they begin to report upward with this information. In other words, they're beginning to derive from their real facts now that they have reflecting their operation. They derive summary reports from that. and send that on up into management above, saying what's happening in their operation, because it's accurate now. And sometimes they'll computerize the summary reports going on up too. That happens quite a bit, actually. There's a sharing of information. They begin to go to meetings with printouts from their reports and make quite a impression of the fact they've got accurate control of their information. It's a computerized report, and it's really nice. Then they begin to realize that other people attending the meeting also have computerized reports. In fact, they're using the same system. They begin to realize that, if you and I, as department managers, would exchange passwords to our information and share our access, we could both look at our reports online, because after all, these printouts we're bringing to this meeting are history. That data is constantly changing back in the operation. As soon as we take a printout, that's a piece of history. It doesn't really still reflect reality. Oh, it's pretty good if it's done recently. But they realize that, they can share this information. So on an appropriate basis, on their decision as managers, and the way they want to run their business, they decide what other managers will I share my information with. I will give those password access or security access to my data, and we'll begin to share this information. And they begin also to merge their information together. In other words, they decide that, if your department's got this report, we've got this one, and if we get together on this and put up a combined report and throw in some new status codes, some new fields, we'll all benefit in a much better way. So mergers of reporting applications are often created. Sometimes the coordinating role will be influential in this, in seeing situations in a couple of operations where some benefits like that could be derived and perhaps stimulate the merger thing to happen. What is really happening, though, when you see this happening, is an operation-wide base of real control information is being established. Down at the working level, the most labor, material-intensive level, the benefits are being achieved right away, parochially initially, and then on a shared basis and growing up, kind of percolating up through the whole operation from the bottom up. So it's not a top-down common corporate database concept at all. It's a bottom-up sort of a process with this whole free enterprise sort of activity going on in the user community. The base is developed from the bottom up and with the best obvious set of priorities. Now, once you have some of this going in the operation, now another beneficial thing takes place is that management is controlling the development. They're responsible for turning these things on, planning and implementing these applications. It works and it keeps working. It works because they'll design it in a way that it will work for them. There won't be any questions about when the design is done that it isn't going to be what they want, because they're involved in the design. They're doing it, essentially. So there's no question about it being a successful application. And it'll keep working, and that's another thing about it, is that management never has a finished product. It just keeps evolving because the company keeps evolving, and knowledge and experience keeps changing, and the more you learn, the more you do better. So, like one of our users back there says, this thing gives me answers, and the answers create new questions for me, and I learn better, are better questions each time and each level. And so it's a continually changing, improving situation. The application's never finished, actually. And that also means when new policies come down through the organization, defining we're going to change the direction of the corporation, or we're going to grow more, or we're going to cut back, or we're going to change. The new policies are implemented by the managers in adjusting their own applications to fit the new policies. So you don't have the situation where sometimes you develop such large, comprehensive applications throughout a corporation, and then a need to change comes, and the corporate management is told that the change can't be done because there's a computer system that's going to take many man years to reprogram to meet these new policies. So we actually have these computer systems affecting corporate policy in that sense. In this way, each user management decides what they should do to change in an appropriate way to meet the newer policy requirements for their operation. That effect then is a corporate-wide computing capability that does change and meets new corporate policy requirements very conveniently. Now, this is not to be implied that we're going to have a form of anarchy out here. And if you just threw out a user-friendly service like this into the user community and said, use it any way you want, boy, you would have a problem. They'd unload the filing cabinets into that thing, and you'd have a real mess. So there is a strong coordinator function suggested with this. And as I say, 10, 12 years ago, when we started to get serious about this and saw how fast it was growing in our organizations, we couldn't control and coordinate the system with simply personal interface between the coordinator and the users. We needed computerized tools to do that. In the initial phases of coordination, when a new system is starting up, the coordinator is primarily a stimulator and a trainer and a demonstrator and these kind of things, doing a lot of tutorial training and helping and guiding, consulting with the users, getting them to get started with their applications. They're brought in, each application is brought in, suggested by the users. The coordinator works with the user, shows them the procedures and methods for implementing the application, signs the experimental report, shows them what the basic rules are, and develops a plan for this application. Now, the plan is basically a resource utilization plan. It is not a detailed keystroke by keystroke use plan. It's a general plan of benefit versus resource impact. That says, in essence, then, that there's going to be a plan for the number of reports in this type of reporting. In other words, in this drawer, we're going to have 24 reports. And we're going to talk about information flow through this data. We're not going to talk about just transactions coming into this database and being carried along there forever. There's going to be new data going in and old data going out. So there'll be a plan developed for the user to keep the database clean. If you load up a system with, just putting stuff in and never taking anything out, obviously the system is going to be loaded up with deadwood, and the majority of the information ultimately will be reference data, and the system will be overloaded because of that. So there has to be a flow of information in and a flow of information out. Every viable system in the world has to have that kind of a flow. When it becomes history, you can make some selections about, I'm going to have a printout of my old items and delete them from the base, or I'm going to dump them on a cassette, or I'm going to dump them on a diskette or a magnetic tape file. But you're going to separate the history from the current information, from the real control information. And that means that the database will be volatile, real-time, and get the greatest benefit from this resource utilization. So there'll be a plan developed for this application. The number of terminals are going to be using it, the number of users, an estimate on the amount of transactions to be processed against that. But within that resource plan, the user is given quite a bit of freedom in terms of how it gets done. So the plan is established by the coordinator, and within the plan, the user will have the freedom. But then, as the plan actually happens, as the database is loaded up and the user actually uses the base, then the coordinator will verify performance to plan, assuring that, yep, indeed, the right resource load is being used here. They are seeing the estimated transaction volumes. We are seeing the database cleaning being done properly, and there's prompting if that's necessary, automatic. It's really exception by plan is what it is, management or coordination. In other words, if the user operates within their plan, they won't hear much from the coordinator. If they deviate from plan, then they'll show up as blips on the coordinator's reporting and be then talked about this change in development or change in use. Quite often that'll simply be an oversight on the part of the user where they just didn't realize that they were going off and doing this little thing that was outside of plan, or perhaps they weren't so clean about keeping their database neat. That might show up on the exception report, or perhaps they've got a new idea. They got this application running here and a major new idea associated with this application, and in the enthusiasm of getting that going, they just neglected to tell the coordinator about this new dimension of the service. Well, as soon as they begin to show as a change in resource utilization or maybe in database size, that shows up on the chart as an exception, and then the coordinator is discussing it with them and saying, what's happening here? And the coordinator then is told, well, we've got this new idea, and we've got to, we want to take advantage of that. And they'll say, well, okay, let's develop a new plan, let's identify the new benefits, and let's have a new plan for this new idea, if it is appropriate. So the point is that the design and implementation is all carefully done in an efficient way, and performance to plan is verified. Security considerations are also a major thing that's considered here. A system must have very good security capabilities, and I'm not talking about simple password security here. I mean, sharing a password is pretty mundane, and you can sit there and guess passwords and break most securities. So you need better security methods than that. So things like the ability to assign access to this particular reporting to a certain station by certain users at that certain station, even in certain time frames on that station. And then within the logic of the security controls, you can build up all kinds of mysterious algorithms of password changes based on all kinds of, in other words, the password can be constantly changing based on some kind of algorithms. You can choose whatever type of security is appropriate, and there's a whole range of things that are right. And if you're going to put some sensitive information like personnel records and that on, you need some of that sort of stuff. Well, the coordinator in this case when they're consulting and setting up a new application, they will be advising the users of the types of security techniques that are available, and based on the sensitivity of this data, make sure and recommend that the user decides to use adequate security techniques. And then assuring efficient system use, and that involves both in the design phase when the application is being brought up, making sure that good techniques are being used, and then ultimately in the actual implementation of the application, ensuring that the system is used efficiently by monitoring the actual use of the application. The tools are there for that. One of the big keys to this whole ensuring performance to plan is a transaction log. For instance, every time you hit transmit on a terminal, a whole bunch of things are recorded about what you did. Who you are, your personal sign-on name, what station you were at, what function did you use to process the data, what was your response time on the use of that function, how many lines of data were processed to do that job, how many accesses to storage were done to do that job, your department number of breakpoints generated. A whole bunch of statistics are recorded every time you hit transmit, and that's one of the big keys to the planned actual control of the system. You do have, the coordinators have access to this accounting information on a real-time basis with real-time functions, and they can go in on a grand scale basis, analyze all use, or go in specifically to a certain user on a certain station in a certain time frame using a certain function, and be that detailed and go down to the step-by-step transmits that that person made and see exactly what went on. The database is equally well reflected. There's a daily process of history capturing. During that process, records are created for the coordinator which reflect the actual condition of the database. The plan as originally established is recorded online, and there are tools for the coordinator to compare the plan actual use of the database, and that's how we verify that the database is being maintained in a clean way according to plan. So there is definitely tools behind this whole system to ensure performance to plan. This is a kind of a summary of that whole function. Ideally, the top sentence there summarizes it all in one sentence. The ideal coordinator would establish and support a productive service that allows the greatest user freedom while ensuring system safety and effective use of system resources. Ideal, a coordinator should report to user management. The reason for that is because the role is one of primarily interfacing with users, stimulating users, deciding which are the best areas to go into the operation to get the most benefits from initially, and talking with users and often making decisions of should we put this on or shouldn't we? Is there a real benefit here or isn't there? And so the more the user knows or the coordinator knows about the real world environment of the operation, the better the coordinating function will be done. It's also nice if this person has some data processing background, at least knows if you're in a multi-system environment that there are structured conventional systems and files there that are in place, and quite often working in arrangement to exchange information between the new systems, the report processing systems, and the structured systems. The data quite often can be used you can collect data in a real-time report structured system and feed conventional systems with this. You can also draw records from the existing system and send them back into the report processing system instead of having the user recreate all records from scratch. So this enhances the value of the records that are stored in the conventional system also, because by bringing excerpts of those into the user system, the users can use this convenient language to turn those records into more useful information. So it greatly enhances the value of the existing conventional systems that are in place too. And of course, there's the semantics and the technology involved in the computer system, and it is a central processor which may have other systems in it. So the 25% knowledge of the data processing of the coordinator relative to data processing is valuable because it is a computer service, and it's nice when he can talk to data processing people, understand what they're saying, and then have some knowledge of the possibilities for exchange of information between the systems. Initially, a coordinator acts as a stimulator. When the new system, you're out there demoing, teaching, guiding, helping, stimulating activity out there, and then that teaching process gets taken over by the user community. Often the training departments will get involved and offer courses to the users routinely by the standard training department in the operation. They'll begin to teach each other and train each other. They'll demonstrate to each other, kind of like the Amway principles. The bubbles keep spinning off and everybody keeps stimulating each other. They'll be teaching each other, responsible for their own turnover of their own people, to be sure that they understand the procedures that they're using on the computer here. People leave their operation, they train the new ones in place and so on. The documentation of the applications is their responsibility, of course, based on some basic policies and guidelines provided initially by the coordinator for the documentation requirements. But eventually this begins, most of that moves out into the user community, and they take care of all that themselves. And then the role of the coordinator changes to one of a governor. In other words, assuring performance to plan, doing the daily resource monitoring and watching for the blips on the reports that show deviation from plan, dealing with the deviations from plan, and of course still working with new application implementations and making sure design is effective. So it changes a little bit in that sense. Now a good system has good controls. Now we've had experience with marketing this system over some years now. There are over 1,000 systems like this out in the field, and we've seen a lot of variety of reactions from data processing when this type of a system is introduced. This system has an excellent set of controls. You can strangle a system down to one little service that's just dribbling out if you want. And in fact, I'm sorry to say that the majority of the sites that have been sold, about 50% of the cases, are using Mapper to develop applications for the users. It's unfortunate when the users could have been shown how to do this themselves, and you've got to know the productivity from that. But because it is such a fast application generator, it does make DP look good to turn up those applications very quickly, but it still does create the situation where the user has to explain to the DP people what they want, and then the DP people use this user-friendly language to develop it for them. It's unfortunate. So the language is perverted in that kind of a case, and of course user design being blocked, you've stifled the innovation and the potential and the productivity multipliers out there by not giving the power directly to those end users. And that's of course a great loss of productivity potential. We've encountered reactions from DP, a lot of unfounded fears, a loss of empire. They fear, the users are going to, take over the empire here. But extremely large amounts of computer service here. The empire is going to get a lot bigger if they'll only encourage this kind of a thing rather than shrinking. The job security idea. Well, let me give you some real-world experience with this job security situation. 15 years ago, we began to push this idea in our factory. And now we were very careful about pushing it to a user-oriented approach. We would never have a user come to us and say, I want you to design an application for us in Mapper. We would also always say, here is how you can design the application yourself, and show them how and let them do it. Always we did this, and we've been doing this for 15 years. Today we have a system there, it's an 1184. That's 4 of the biggest processors that Sperry sells, put together in a multi-processor environment. They have 3,000 terminals on that system. It runs a Mapper service in there along with a conventional TIP transaction-oriented type service, about 100,000 transactions in the TIP environment, and about 400,000 transactions a day in the Mapper environment. They'll process over 400 million lines of information in a day, turning data into information with that system. It is a very large service. There are over 3,000 applications in that system that are production applications that were developed by end users in all those offices throughout the operation. So we've been pushing user-driven computing into this operation for 15 years, and you'd say, well, they must have eliminated the DP department then, right? Not at all. Our DP department is bigger than it ever was. It still has a backlog of 2 years for conventional programming that has to be done, and they still have a bunch of open recs for programmers which they can't hire. Don't underestimate what people want to do with computers. There's so much that they would like to do. Now, if we'd have gone conventional, all of that computerization would not have happened in our operation, and our factory would be a much worse environment of productivity, and we were able to grow to many magnitudes of growth without having to hire all the additional people for that, because those people got to computerize all their operations, and their control is so much more effective. Their plans are being met a lot better too because they've got the accuracy out there. We could not have computerized all that if we'd have gone the conventional route, and yet data processing still has a lot to do. So just relax and think about all the potential of what we want to do with computers. This James Martin quote is from his book, Application Development Without Programming. If you haven't read it, I'd highly recommend that you do. It's a book about the whole approach to users as application designers. And he says sometimes end user groups armed with new languages like Sperry's Mapper are more innovative than DP professionals will dare to be. He made that statement after visiting Santa Fe Railroad. This was our first customer that bought a Mapper system back in 1975. And this was an operations group of people in the rail yard in Chicago that needed real-time control of way billing, car inventory control, and forming of trains. And they were getting a very slow response from their conventional DP in getting it done. They were showing this, and the operations people, these are the people in the rail yard, decided that they could use this system to develop their own applications. And they did. They were our first customer, and today they're our largest customer. And they are now controlling over 100 rail yards with this system. And it is, and James Martin has indicated, that is the world's largest user-designed computing system, and it certainly is. So what is a proper role for data processing as we look into the future with this type of service being offered? We should take the role, first of all, as caretakers of computer power, establish these inter-system data links. This whole network of computer service we need is anybody who's, you pay attention to what's happening in communications technologies and central processor technology and all, and peripherals and all these kind of things. A lot of complex capabilities requirement there, and we need the people who can develop all those centers, deliver the power and the communications networks that we need. This is a major task and a very important one. We might think about this role as being a little bit like the electrical utility power management people. They're concerned about the plant control, the creation of the electrical power generators and this sort of thing, looking ahead, making sure there's enough capacity there to deliver all the power that's needed as the requirements increase, establishing the delivery systems that'll bring that power out to our homes and into our businesses and that sort of thing. But then beyond that, they don't tell you how to plug in the toasters and how many refrigerators you need, or what you're going to, or TV sets, or what you're going to do with these things. They'll advise you on efficiency and things like that, and that's the proper thing to do. Consultants to user designers is a major new type of business that's important to this new way of doing business with computers. Those users do need advice, especially on the larger application designs. They need help from the people who are experienced in major application development, guidance, policies, guidelines, things like that, and they need help along that line and specific consulting relative to individual applications. So there's a great deal of help that can be given along that line, and I think this is going to be a major service that data processing will be offering. It'll be very helpful. Promoting the best system used by the users. In other words, going out there and identifying through the measurements of the resource utilization of that and indicating where we could improve efficiencies by improving the way the users are using these systems. They like that kind of help, and they really appreciate that kind of service being delivered to them. And the ability to eliminate that visible backlog is also very nice for the DP department. And all of a sudden you're perceived as a much more service-oriented organization that is really responding in a way that they really appreciate. Now, I'm not talking about some futuristic thing that's going to happen a long time off. I'm talking about real-world situation that exists right now. Sperry Corporation, with this Mapper system, has installed, in fact, there's over 1,000 of these large-scale systems existing throughout the world. Very popular concept, report processing. It's been used in many different native languages. In other words, they translated it to German, Italian, French, all these different things. Report processing in those languages, and the diagnostics are in their native languages. There's 2 languages in Japan. Japan likes productivity, and believe me, they've really gone for this idea. There's over 100 systems in Japan of this kind. Some of these systems are large, some with thousands of terminals online. The one back in Roseville has 3,000 terminals. We have another one in Bluebell headquarters, almost equal in size. Another one in Salt Lake City that's almost equal in size. Another one down in Bristol, another one in Rodelheim, Germany, and there's many more than that. Some of these systems are used simultaneously by thousands of users online. Very large services being delivered. Millions of transactions on a given system per day. Hundreds of millions of lines of information, searching, sorting, totalizing, turning data into information being processed. How applicable is this? What kind of a range? This is not all the customers. This is just a sum of variety to show you what the variety is. Within Sperry Corporation, we have 1,100 systems using Mapper. We use Mapper to run our company. GTE Automatic Electric, it's manufacturing control. This is in a factory in Chicago. Kansas City Power and Light utility company using it for personnel and administration of their power utilities. Bechtel Corporation is a construction engineering firm, one of the world's largest. They use it for construction contract administration. The administration in Kansas City state government. Carnival Cruise Lines has got some casino ships out in the Caribbean they're using it to run their casinos with. Chicago Board of Education, administration of the schools. Floral Network Incorporated, that's FTD Florist. You've probably heard of those people. They use it for floral order entry. And in Santa Fe Road, of course, is our biggest system user, and there's many more. There's over 1,000 systems. All the way from delivering flowers to delivering, controlling railroads. Report processing is universal. Who doesn't need the ability to have a report generated that quickly without programming? Who doesn't need the ability to have real-time updating and reflection of real events in their reports? Then the ability to take these functions and search and sort and totalize and do these things to turn that data into information without programming. And then ultimately with a very simple procedural language concept, be able to use all those instructions for application development. It's very universal. We'll talk about system considerations. If you wanted to go out and get a user-oriented system, these are some of the items that are shown here. In my book, I go into this quite extensively because it is important that a proper selection is made here. You want software, hardware expandability upward. You want to go into the proper entry level without costing an arm and a leg for the amount of service you want to deliver initially, but look to expand that service because we got all that computing to be done out there, and it will grow, believe me. So you want hardware modularity, so you can increase the hardware, and then the software should be expandable right up through that without changing it. Good support facilities, a functionally complete system that's got all the functions you need, easy to use. Now that's one that's not tough. It's not easy to decide whether it's easy to use. There's only one way to determine that, not by reading the specifications and the glossy brochures. You can forget that because they'll all say easy to use. You got to actually implement an application. So get a user committee or a user or two and take each of your cases you want to consider and have them implement applications, and then determine from those users designing those applications, decide, is it really a user-oriented system? Is it really easy to use? It's the only way to do it. You've got to test drive these systems in order to find that out. Adequate security, as I said, not just simple passwords, but all kinds of mysterious algorithms, the ability to lock things into given terminals to individuals, even in time frames. Good education and documentation are obvious requirements, but on this type of system, online is important. Good online tutorials coming back to you with all kinds of online help and responses to error conditions and things like that are very essential. And then the bottom one, which seems to be lacking in most of the 4GL stuff I've seen around so far, tools for coordination. And to offer a system like this without tools for coordination, well, obviously it's not too wise. It's a very important decision because once you introduce this service, it will grow, believe me. Great programming cost savings will be had by this kind of a system because we're designing real-time applications, and when you try to do that conventionally, the cost would be just prohibitive as heck. Fast, extensive productivity gains, as we talked about throughout the operation. Real control information is established with this approach, and then growth and timely change is also supported. People who lead into this new world will become heroes. We've seen a lot of that already happening in all the installations we have. Computer power is addictive, and users do love it. They don't like the drudgery of paper mills and all the inaccuracies of the information processing they're doing without computers. They just think it's great when they can have this additional, more effective control of their operation. And they like the people who deliver it to them, very much so. Great gains are quickly achieved at all skill levels. All these functionalities, each user can choose the appropriate functions that suit them with their skills in this particular situation and have a productivity benefit from that. Or the more sophisticated ones that learn some of the trickier stuff to get greater benefits from that. And there's been some incredible cases of people coming out with having a knack for this that develop just some incredible capabilities of developing these kind of things. The system evolves and remains currently applicable. In summary then, we've got a lot of information to be computerized out there yet. This whole invisible backlog that I call real control information is mostly to be computerized yet. Only the users can do it. There's no way we could hire enough people, or we couldn't even hire enough spec writers to write all the specs to explain all the things we'd like to do. So this is the only way. You've got to get the users involved in the computer power, and it's highly advisable that both DP and operations management support the idea. If one or the other, well, operations management will like the idea, believe me. When they're showing the ability to do these things with computers, they like it. It's DP that sometimes holds back and says, well, we better not do this. It makes us all nervous or whatever. And then they'll lose in the end because eventually this is the way that things are going to go. So it's better if they are supportive of the idea. Unfortunately, I do see that as a general trend throughout the industry. DP is beginning to recognize the importance of getting users involved and are beginning to help the users get involved. And that's the way it really should be. The last phrase at the bottom just refers to the old adage about, you know, give me a fish and I'll eat today. Teach me to fish and I'll be able to eat for the rest of my life. And that's the way we have to do it with computers. Instead of giving the users the individual programming requirements that they have, teach them to use this computer power to develop their own applications and let them become fishers of computer power. Thank you.
We have 5 minutes or so for Lewis to take your questions. If you do want to ask a question, can I ask you to step up to the microphone in the centre aisle, state your name and your affiliation. Yes.
Andy Bennett, South Australian Ministry of Technology. In your summary of the role of computing professionals, you said essentially they'll become caretakers of computing power and consultants to the users. Do you see any applications at all being left over for the DP profession?
Yes, you mean using this type of a language?
Yes, what categories would
Yes, they do. They do it a lot right now. As the new installations are going in, very often DP will take a role of designing the applications for the users. And that's not all their fault, because it takes a little while to get the users to become experienced enough to develop their own applications. And sometimes in the initial installation, you have a major application or two that is justifying the purchase of a fairly good-sized system, and so DP will do the development. And I think even as the systems evolve, there will be some applications that users will ask DP to do most of the design with, because they might be corporate-wide applications like an order entry system or something very large like that. It isn't that the users couldn't do it themselves, and ideally they should be guided by DP to do it themselves. This has happened in a large percentage of our installations, and it works very well. In fact, it's one of the best ways to do it. But they do a lot of application development with this type of a system. That's okay. I'm not saying that that's bad. I'm saying that what is bad is if they were exclusively doing it that way and taking a language like this and only using it themselves to deliver the service. That's where you're really hurting the company or the operation that you're in, because then you're cutting off all the other potential for all the small application development and all the multipliers that are involved in that.
You can go to this gentleman if you like to queue. Just this gentleman's got the floor.
Derek Spear, Manukau Technical Institute, New Zealand. When languages like COBOL came in, we saw a substantial decline in efficiency from assembler programming. As products like the one you've been discussing today become more widely used, are we going to see a similar decline in efficiency from the relative efficiency of, say, COBOL?
Okay, good question. I'm from the development group back in Minnesota, so I'm very biased in my opinion here, of course. So let me give you an example of an opinion that was done by a mapper installation, and this was written up, by the way, in the use proceedings. The 1,100 users in the United States in the fall use proceedings. It was Doug Morgan, the director of data processing at Kansas City Power and Light, one of those customers I had up here before. And he made a study of applications use in his computer. He's got an 1182, which is a large-scale multiprocessor. He's got half of his system running conventional TIP, CMS, DMS types of things, database kind of things in there, conventional systems. And he's got half running mapper. And he's a very strong proponent of a user-driven computing. In fact, that was the subject of his paper. But in the end there, he did some analysis of application development efficiencies and productive use facilities, which were just astounding, because it was the first time anybody had ever done a large-scale comparison between large-scale services like this. And well, there's a measurement called a standard unit of processing in the 1100 system, which is a formula which combines computer power and I/O activity, and gives a standard unit of processing that applications are measured by when they execute. And he had results, SUPs they're called, on all these different applications, and he found out that he could do 50% of his production with Mapper, including development and production use of that system, with 3.5% of his SUPs. And he was very amazed by that, and we were a little amazed by it too, because we never had the opportunity to compare. So in terms of efficiency, there just may be an improvement, in this case, on this system, from those statistics. And it's a pretty major sample, and I think it's a very interesting one.
Just have time for one final question. Thanks. Gentlemen.
My name is Elias Awad, University of Virginia. As you know, being a futurist, not that I am a futurist, but predicting demand for programmers ranging anywhere from 300,000 to 28 million obviously depends on a number of conditions, number of things happening in the next few years. But more recently, I've read a study whereby they're predicting 1.8 million software engineers before the end of the decade. Obviously, they're taking into consideration the role of the PC and the change, the trends that are taking place in the personal computing, primarily for a small user or personal computing network to a mainframe. Now, I'd like to know, based on your experience, where you see these jobs or this particular new position taking place. Would that be a replacement of programmers? Would that be a part of the increase in the programming effort? And part two, given that, and I agree with you 100% about the role of the DP professional as a consultant for the user or to the user, where do you see the information center as a concept, perhaps improving the kind of a interface that you have between the user and the new system?
Well, as I say, there's still a great deal of demand for conventional application development, and that's not going to go away in the very near future. I don't see all systems being designed with, these kind of languages. In the case of our DP department back there, their role has changed a lot from the standpoint of what they do now in comparison to what they did before. They do have their conventional systems in place and all the large database systems and all that are structured and disciplined in there with conventional concepts. And we have this large community of users out there doing their thing with their applications. And as I say, there's a great deal of exchange of information between those two systems. So the people who can be knowledgeable about both sides of the fence, and I don't know if this is what you mean by information engineers or that sort of thing, these people will become more and more valuable because they can actually make better trade-offs between the different applications. The term information center is one that I have heard. I don't really see it as a particular, it's more of a technique than a way of bringing together to the users an offering of a whole variety of services that they might take advantage of, such as the PCs and the fourth generation languages, and making kind of a smorgasbord available for them, and then the service center acts as a consulting service to the users, helping them. I think that's a good idea, and the more you can help the users along into this new world, the information center concept certainly has some validity there, I would think, too. In our situation, we didn't call it an information service center. It was more of a coordinator's service that we were offering to help the users into this world. So it's a new term.
Unfortunately, we don't have time for any further questions. I'd just like to call on Professor Tony Montgomery to close the session.
Ladies and gentlemen, Mr. Louis Schlueter, on behalf of the Australian Computer Society, I'd like you to accept this small token of our gratitude for excellently preparing and presenting a keynote address to the 10th Australian Computer Congress. I'd also like particularly to remark upon the UNIVAC Corporation, who has sponsored Mr. Schlueter's complete expenses to come to this conference, to be registered at the conference, and to be fully accommodated and flown out here from the United States. So if you could please thank the Univac Corporation for his sponsorship on this occasion. Get on the bit size here, most certainly the common size any outside here. Yes.
Design, computing, published by Lexicon Books.